Make it bounce here with a little bit of simultaneous equations. What do you reckon? Okay, so for simultaneous equations, we've got two linear equations. Now, those two equations given up there, why are they both linear? Well, they're linear because they've got x to the power of 1. So they don't have, remember the idea of a quadratic equation is that we've got like an x squared. Now, those don't have x squareds, they've got x, and that's just like x to the 1, x to the 1. So, therefore, they're linear. They draw straight lines. So, you see that? Line, straight line. Okay, yeah, enough of that. So, let's go for it. So, for simultaneous equations, let's just look at each equation by itself. So, I'm going to consider equation 1 by itself. And I'll ask you, give me a coordinate pair. In other words, an x and a y that is true for that equation. This is one of those ones, again, I have to guess what you wrote. Now, I'm sure somebody, was it you that wrote 2, 3? Maybe there was somebody who wrote 0 and 5, because 0 plus 5 gives you 5, or 5 and 0, or 1 and 4, or those type, but there are lots of these examples, right? And maybe you wrote none of those, and, maybe you wrote one of those, and you were like,
I wrote that one, that's the one I wrote.
Or maybe not. So, that would be that one. But let's have a look at the other equation. Let's go here and say, so in this one, there could also be quite a lot, right? So, give me one pair that works for this equation over here, and do you think I'll guess what your pair is? Okay, well, I feel less likely for this one, but 2 times something minus something else is going to be 4. So maybe like 2 times 3 would give me 6, so I'd have to subtract 2. I wonder. I'm hoping that somebody had a negative y value. That would be quite creative. But again, there could have been a few other examples, right? If we had put maybe a 1 in here, we're like 2 times 1 is 2. What do we need to subtract? We need to subtract negative 2. So that could be another example there, right? 2 times 1 is 2. 2 minus minus. Okay. I don't know. Right? So you can tell me later if that's... But again, the point holds that, hey, look, there are lots of things that seem to work for that one. And there are lots of there. And they're infinitely many. And so what is it? What do I mean by that? Infinitely many? Well, they're infinite. They're, as many as you like. There could be more. Okay, so, you could walk... No. Okay, so what I was thinking is, is of that number line and going to negative infinity and walking out the classroom, being encouraged to keep walking. It's not very nice, is it? Okay, so we've got these examples. Now, what we want to find, and this is going to be a challenge, I want you to find a pair. Now remember, the order does matter. So this one here and this one here are different because it's x, y. It must be in that order. So I challenge you to find an ordered pair, an x and a y value, the one that's gone behind my head. Where did it go? Maybe if I put it, above my head like here. So if I put my ordered pair over... Somebody made me the devil, who? Okay, so if maybe not over... let's put it back over here. Okay, so now your challenge is you need to find an ordered pair, a set of coordinates that work for both of these equations. Not just one of them, but for both of them. So challenge, to get you to do this, you go... It still has that punchy effect, doesn't it? Okay, so go for it. Okay, so you've gone for something, and I'm going to be like, I don't know, you must have spent quite a while. 1 and 2, 3 and 4, 5, I don't know. So it'd be great if we had some sort of approach to do this. So our approach. We're going to rewrite one of the equations in the form x equals or y equals. And we're going to substitute it into the second equation. which means we'll find one of the answers. We'll either find x or we will find y, and we'll use this to find the other. So let's jump straight into this one that we had. So I think we had our Lelo one first, right? And so we highlighted that. So you know what, how about this? Let's just go for it. X plus y equals 5. I'm going to rearrange this one. So I'm going to say, I could write that as y equals 5 minus x. You know, I've subtracted x from each side. That seems valid. So whenever I see a y in this equation, I'm going to write this version of y. So in this second equation, we've got 2x minus y equals 4. But I'm going to write that one over there, because that's another way of writing y from the first equation. So let's put that in and go 5 minus x. How many different variables do we have in this equation? Okay, well, I was wondering if I've asked that well, because we've got 1, because we just got the x that we don't know. So therefore, if we've got one variable, one equation, we can solve it. Now originally, we had 2 variables and 2 equations, which always just screams out simultaneous equations. So go for it, solve the equation, and what do you get for x? So I'm going to go for it. How quickly do you think let's go for it? Now, 2x minus 5 plus x equals 4. 2x plus x is 3x plus equals 9x equals 3. Didn't get that? Let's rewind and just watch that again. 2x minus 5 plus x equals 4. And then he went 3 plus x, and then it was coming, and a whole lot was going, and it was the race was going again, and x equals 3. Oh, man, that was too good. Let's get back to real time. So we've got x equals 3. Now we want to find out what y equals. We found x equals 3, so we can just substitute this. And let's substitute it. It feels easiest to do it in this equation. So we're going to put that back into that equation. Now it suggests you keep going, working your work down like that. But I'm going to put it here because we can see it all on screen and go y equals 5 minus 3, which equals 2. So in other words, our answer is 3, 2. Oh, do we have 2, 3? We were close, eh? That was a 3, 2. We actually had the answer over here. I know somebody, and I'm not going to ask you because I'm going to look forward to seeing this. Did any one of you just go 3, 2? We had the answer there. Okay, well, there we go. So there's our answer and there's our strategy. So let's run through. We got 2 examples to do this and go for it. So solve simultaneously for x and y in the following set of equations. I want to take us through this one again because I want to kind of get that feel of that momentum. So, you know, if you feel a bit scared, then we've got x and y as 7. But y minus 2x equals 1. And we need to solve simultaneously in the following set of equations. And can we do it? I don't know if we can. But I have full faith in you. Okay, so let's go for it. We've got our 2 equations. I'm just going to rewrite them here. I've got x plus y equals 7. And the other equation is y minus 2x equals 1. It is entirely up to you which one of those you manipulate into what form. So, you know, I want to run through them quickly. You may have gone y equals 7 minus x. You may have gone, you know what, I want to do this as x equals 7 minus y. And then put that into the other equation. You may have gone, but we're there, y equals 2x plus 1 and put that into that equation. You might have gone, well, x equals... Well, this is going to require a little bit more work because it's like a half y minus a half. That's the one that maybe I'd suggest not doing. That looks too complicated. So I'm going to choose one, and I'm going to choose one slightly differently and just go y equals 2x plus 1. So I'm going to take this now and say that there I can replace this y with. Okay, so I'm going to put that into that y. So we've got x plus, and always brackets, brackets, brackets are helpful. Why are brackets useful? And think of the previous example. Okay, and I've asked this question to you before, and the answers were fantastic back then about, you know, if you've got a negative, you remember to actually distribute this negative into the brackets. Okay, so x plus, now y, we've got another way of writing, which is 2x plus 1, and that equals 7. So we've just taken just so much fun. I've got that energy. So we've got x plus y equals 7, but now we've got another way of writing y. Then that's 2x plus 1. So we've just replaced the y with 2x plus 1. So initially, 2 equations, 2 variables. Now, 1 equation, 1 variable, solve, and what do you get for x? Okay, I'm going to do it. How about this? We can just go, well, I'm going to go, these brackets aren't actually doing too much, so I'm speeding myself here. I'm going to go x plus 2x is 3x. I'm going to subtract 1 from each side. X equals 2. I'm going to sub into this value here. Y equals 2 times 2 plus 1. So y equals 5. So our answer is 2, 5. And let's just get all of that again. X was 2. And then what did he do? And he went y equals 2. And it was like up there, it was going. And okay. And you were like, yeah. So that is what we got, 2, 5. So it should work in either of our equations. So 2 minus 2 times 5 equals 1. Wait a second. So do you see the problem and the usefulness of checking your solutions and rushing through at a rate of knots like I've done over here? Let's just check. Wait a second. If we substitute this in, y minus 2, let's just go. Well, y was 5 minus, well, x was 2. 2 times 2 is 4, so it seems to work. So all that rushing was actually fine. But it's nice just to check your answer if you want to. So let's head into our last example together. Solve simultaneously for x and y in the following set of equations. And somebody said, isn't it nice to work with music rather, right? So we've got 2x minus y equals 8. X plus 2y equals 9. And we need to solve simultaneously. It's not really working. Or is it, where's it working? Okay, so let's go for it. What are we doing here? We're solving simultaneously. So we've got our strategy. And 2x minus y equals 8. And we've got our other equation, x plus 2y equals 9. We've got 2 equations, 2 variables. What is it screaming out to do? And this is like one of those, what's the first thing you do when you factorize? What it's screaming out to be done is to solve simultaneously. Now, just to show that things might be a bit different, I'm going to do something a bit different in this one, just to show we could do it. X equals 9 minus 2y. And I'm going to replace the x with that value, just so that we mix it up a little bit. So we've got 2x minus y equals 8. But we've got a new way of writing x. We can write it as 9 minus 2y. So 9 minus 2y. So we've replaced the x with this version of x. So now our first solution is going to be y, and then we'll find out what x is. And that works nicely. So let's go through it a bit more gently this time. I'll still give you a chance. What's your full coordinate pair? So what is your final x, y answer? And then I'll go through it nice and slowly over here. Okay, so I'm always interested what you write, and then I see, okay, well, cool, looks like you got the same one I got, or oh, it looks like maybe there's a little slip there or not. But you're always writing something and trying something, and that's what's beautiful. So that's what we like. And let's see. So I'm going to distribute this in and get 18. Going to distribute this in and get minus 4y. Minus y equals 8. Okay, 18. I'm going to subtract 18 from each side. You may solve this differently. So you might get tired of me saying this, but I really, really mean it. You may solve this slightly differently and get the same answer of y, and you could have followed great logical steps. So yeah, maybe it's different, that's fine. What I'm thinking is minus 4y minus y is minus 5y. And I've got 8, and I'm going to subtract 18 from each side. That's my thinking over here. So I'm going to have minus 10. Okay, well, I just want to divide both sides by negative 5, which would give me y on the left-hand side, which is what I want, and gives me 2 over here. But maybe you kind of subtracted 5 y's from each side or did something else, and it could have worked as well. Now we've got x equals 9 minus 2y. So x equals 9 minus 2y, right? That was our equation, I think. So I'm going to put the y in here. So x equals 9 minus 2 times that 2, because y is 2. So x equals, well, 2 times 2 is 4, so 9 minus 4 is 5. Of course, there's this other thing that was banned last year, but this year you can use it if you want. You can have a calculator and go on 9 minus 2. I don't think that's necessary, so goodbye, calculator. No, it's only when it appears that it has that beautiful music, right? So our final answer we get is y was 2, x was 5, and yes, we need to always make sure it's in that order, x, y. It's alphabetical, that helps as well. So that's that. I think exercise 21 is the next one for you, and you know what? Let's say goodbye with a little bit of that music.